Okay. And so what osmosis is it's the movement of water. Okay? It's the movement of water from high concentration to low concentration so from high concentration to low concentration until it's equal. So the water is trying to equal out. So when you put the egg in the water entered the egg because where is there more water? Outside of the egg or inside of the egg? Inside. When you put it in the water, why did the egg get bigger?
Because there was water on the outside.
Because there's more water on the outside. So the egg got bigger because there's more water on the outside, so the water went into the egg. Why did the egg get smaller when you put it in the corn syrup? Where was there more water? Inside. So the water left the egg in order to equal itself out. Okay? So there's three types of environments. The first type of environment is isotonic. You've heard the prefix iso before. All right? What does iso mean? It means not two. When have you heard iso before? Geometry class. Isosceles. In an isosceles triangle, what is true about an isosceles triangle? Two of the sides are? Two of the sides are equal. Iso means equal. It means equal. So iso means equal. So what do you think is true about the water inside and outside of the cell? They're equal. Yeah. So water is equal in concentration inside and outside the cell. So if the water is equal, what does that mean about the solute? Like, let's say I have a picture of my cell. I'm going to draw a cell here. Give me a number, a nice round number, maybe a multiple of 5, in between 1 and 100. 50 is boring.
25.
40. We'll go 40. All right. So inside the cell is 40% water, and I'm going to use the abbreviation for water, H2O. So if this is isotonic, what has to be true about the water outside of the cell? Has to be the same. So outside of the cell has to be 40% H2O as well. So if I have 40% water inside the cell, how much solute is inside the cell? 60%. Perfect. Yeah. 60% of solute has to be inside the cell, which means that the 60% of solute outside the cell. Right? Because if it's 40 plus 60 has to be 100, 40 plus 60 has to be 100. So what is true in isotonic? What is true about the solute as well? The same, yeah. So solute is equal, solute on the inside is equal to the solute on the outside. Solute inside is equal to the solute on the outside. So what's going to happen to the cell here? Is the water going to move out of the cell or into the cell or both? It's going to stay where it is, right? And so here's what happens. Water keeps moving because water never stops moving. It's going to go into and out of the cell equally. So what's going to happen to the size of my cell? Yeah. The cell stays the same. The water will move in and out equally. This is kind of what happened to your vinegar egg, although there is a little bit of difference between them. All right, so yeah, stir those up good, and then fill them all the way up to the top, and then get 2 more Erlenmeyers and dilute them up.
Do I use these ones to stir it up?
Yeah, you can use those, or you can look for a stirrer in the cabinets. Okay, are you guys good? All right. The next one we're going to do is we're going to skip down to hypertonic, because this one's going to make the most sense to you guys because you already dealt with the hypertonic one. The hypertonic one, hyper means above. Like when you're hyperactive, it means you have above normal activity. When you're hyper, you have a lot of energy, right? You have more than normal energy. Okay, and tonic means strength. So this basically means above solute. So this means, do we have a lot of water? This is like the corn syrup. So in the corn syrup, do we have a lot of water or a little bit of water? A little bit of water. So in this case, the external has less water than the internal environment. And that's concentration, not amount of water, but concentration of water. So I'm going to draw my cell a little bit bigger this time, just so I can write those percentages without having to write them really small and have my stuff look icky. So I have 40% water and 60% solute. Okay. So if the outside has less water, I need a number here that is less than 40%, right? Well, 20. Good. 20 is good. So the 20% water, which means how much solute is outside? 80. Okay. Now remember, water always wants to go from high concentration to low concentration. So where do I have the high concentration of water, inside or outside? Inside. I have a high concentration inside. So it's going to go from the big concentration to the small concentration. So what's happening to the water? Is it entering the cell or is it leaving the cell? Leaving the cell. So in this case, the water leaves and the cell does what? Deflates. And I'll call deflates, I'll leave it with your vocabulary, that's fine. But I'll call it something even easier. The cell shrinks. Okay, so we end up with a shriveled cell, just like the egg in the corn syrup. Are you guys good? You see a couple people still writing, I'll let you catch up. You still have plenty of time. Okay. If you still need time, you can take a picture of this or you can borrow it, and I am recording it. I will post it. Okay? Yep, on YouTube. All right, over here we have hypotonic. So if hyper is above, what do you think hypo means? Below or less. Like a hypodermic needle, it means hypodermic means the needle is going under. Hypo. Derm means skin. Hypodermic needle means the needle goes under the skin. It injects the medicine under the skin. That's why it's called a hypodermic needle. When you have hypothermia, it means your temperature is below normal. The opposite of hypothermia is hyperthermia, meaning your temperature is above normal. Okay, so in this case, what is true about the water? Where? In the cell. There's less in the cell. So the external has more water than the internal environment. Okay, and so we're going to use our same example we did last time. I'm going to draw the cell kind of big. Nice and big. Thank you. Grab one of these. Okay. 60 and 40 again. Okay, so that means we need more water on the outside, so give me a number higher than 40. 60. That means how much solute is outside? 40. Okay. And so where do I have more water, inside or outside? Outside. So I'm going to circle that, and then I'm going to draw an arrow to the low amount. So what's happening to the water here? Which way is the arrow going? Inside. So the water enters, and if the water enters the cell, what happens to the cell? It grows, yeah, it gets bigger. So cell grows. Occasionally, what happens if the cell grows too big? Can pop. Yep. Okay, so couple of ways to remember it. Hyper, right? When you think of like shivering, right? When you shiver, you get colder and you like bundle closer and try to get smaller, right? So her. Another way I used to remember it is coffee makes me hyper and it stunts my growth, right? Coffee makes me hyper, it stunts my growth, right? Smaller, okay? Another thing to remember if you do the opposite, hypo, big O, right? Gets big, grow, hypo, grow, Kind of sounds the same. Hypo, grow, hyper, gets smaller. Hypo, big round, expands, could pop.
How do you do that?
How do I do that? Practice. Pop. Now, everyone wash your hands because you just put your fingers in your mouth. All right? You're in a gross bio class. You just put your fingers in your mouth. So, okay? All right. One more thing I want to add. Let's go back over here to the sides over here just so you have it. Just so I say you have it. Okay? In the hypotonic, the solute inside is greater than the solute outside. And in the hypertonic, you only have to remember one. The water is always opposite. So if you remember water, that's great. If you remember solute, that's fine too. Whichever way helps you remember it. These are something that you do have to kind of memorize. If I put a cell in a hyper environment, it's going to shrink, making beef jerky, putting the egg in corn syrup. If I put a cell in a hypotonic environment, it's going to grow.